Assalamualaikum and hello everyone. My name is Muhammad Daniel Putra bin Shahrul Nizam, metric number CE200225. So, I will explain how to use MATLAB. So, in the lab 2, it have two parts, which is part A and part B. So, part 1 will explain how to use Simulink. So, the first is how to starting a Simulink. So firstly, you must open the MATLAB, then you can type in command Simulink or and then you just press enter or you can click this button. Okay, it will show like this. Simulink, it have blank model, blank subsystem, blank library. So you click the blank model, create model. Right, so it will show like this. Alright, so after we create a blank model, we see in the procedure, you must to download simple SLX file. So, we open the blank model and then we just click this, open. Okay, so this is the download about the files. So, we click open. Okay, so this is the model that it will download. So this is a step which is for the input. This is the transfer function, and this is scope. Scope is for the output. So these elements can get from library browser. Okay, in the library browser, it have commonly used block, continuous, dashboard, discontinuous, discrete. This is about source, sync. Okay, so after we create a block, so we can modify the block, which is you click the transfer function. Okay, this is block parameter. So this numerator, this is denominator, absolute tolerance. Okay, so we see we change the denominator field to 1, 2, 4. So I change it 1, 2, and 4. Then click apply, click OK. So it will be different like before this. After that, we click the block step. So step time is 1, initial value is 0, final value is 1, and sample time is 0. So okay. So this is the scope. Okay, the scope is nothing because I don't run the simulation. Okay, so for the running simulation, we just click run. Okay, so we click the scope to see the output. The output like this. So after that, we must change the transfer function block to 1, 20, and 400. Okay, I'll change it. This is the transfer function block. So change to 1, 20, and 400. So click apply and OK. Oh, so we click run again. Okay, so after it finish the loading, we click the scope and see the graph is different like this. Okay, so we open the model configuration parameter from the simulation to adjust the start time and the stop time. Okay, model configuration parameters. Okay, start time 0.0 to 0.8, 0.0 to 0.8, and then the stop time change to 10 to 2.0, 10 to 2.0, 2.0. Okay, click apply and OK. After that, we click run again. Okay, click scope. So the graph will different like before this. So for the building system simulation, I have done to place the step, the sum, the gain, the PID controller. This is the transfer function, and this is for the output, which is scope. This is the line, which is the to connect the program, to transfer the program from step to sum, then sum to gain. So we click a run button. So we see this output like this, and then we change the gain to, okay, then we run. We click the scope, so the output will be like this. So that's all for me for the part A, and it will continue for the part B. Thank you.
Assalamualaikum, my name is Muhammad Faiz bin Hamidun, metric number DE20024. Today I want to explain about part B, transfer function. Okay, first you have to open MATLAB, then you have to open Simulink. Create a model. Now double click at the blank page. First we need step. Okay, then we need transfer function. Okay, and finally we need scope. Next we put the transfer function. Then click apply. Okay, expand it a little bit. Okay, next we have to connect this step to transfer function, and transfer function connect to scope, and then click run. Okay, after that we need to click on the scope to see the waveform. Okay, this is the waveform. Okay, next we go to the lab sheet. Observe, record, analyze and discuss the characteristic and transient response, maximum overshoot, rise time and setting time of the transfer function. So we go to, okay, next we go to comma window. We have to write some coding. And now we got the rise time, transition time, setting time, overshoot, undershoot, peak time. This is how to show the result on the figure. This is for the peak response, rise time, setting time, transient time, and lastly steady state. Okay, that's all from me. Thank you.